No.
Okay, I want to show you today how to figure wind direction on an isobar map. So you've got high pressure, you've got low pressure. The isobars represent lines of equal pressure from high to low. Okay, so it's not that hard to figure out wind direction at any given point. I'm going to start with a really easy one, which is this point right here. Okay. Now, if I want to find wind direction at that point, I need to know two things. Well, I need to know basically which side of this isobar has higher pressure and which side of this isobar has lower pressure. Now, obviously, here's a high. So as you work our way out, this side is going to have higher pressure than this. So higher pressure here, lower pressure here. That means the pressure gradient force always goes toward lower pressure, perpendicular to the isobar. Now, because of the rotation of the Earth and the fact that large bodies of air are deflected, and again, we're talking about an area that's probably could be 1,000 miles or maybe even 2,000 miles across here um, on this map. What we get in the northern hemisphere is Coriolis force pulling the wind to the right. So what that means is to the right of pressure gradient force. So in order to figure that out, I just turn my map temporarily so that the pressure gradient force is pointing away from me. And then perpendicular to the pressure gradient force is Coriolis effect. It will push that way, and then the resulting wind will be between the two. So there's my actual wind. Okay? So I go back to the original, and provided that north is at the top of my map, which is standard, this would be a northwest wind because it's coming from the northwest. All right, so there's my wind. All right, now I'm going to do a wind over here, southwest of the high. Where's higher pressure? Where's lower pressure? Well, higher pressure is again on the inside of this isobar because this is building up toward higher pressure. Lower pressure is on the outside. So there's my pressure gradient force. My Coriolis effect I'm turning it again. There's the pressure gradient pushing away from me. I'm going to be to the right with the Coriolis effect, and my wind will be between the two. And so as I come back, that is roughly what I would call an east wind coming out of the east. All right? And I'll do one more north of the high. Let's do it here. Okay? So that point north of the high, again, the highest pressure is on the inside of this circle, the lower pressure is on the outside, so pressure gradient force is perpendicular. Coriolis force is to the right, and my wind is like that. Now I can generalize because if you think of this in 3 dimensions, the air is actually descending toward the Earth, and as it does, it is diverging. And as it diverges, it wants to get away from the high, push outward. It's being pushed. It's almost like you had a leaf blower that you're blowing at the ground, and everything blows outward from it. What will happen is the wind will diverge, but it will be deflected by the Coriolis force, like so. So I can generalize about my wind and say it's going clockwise and it is diverging from the high. That is my wind. That is what we call an anti-cyclone. Fair, dry weather. All right, let's briefly take a quick look at the low. Same concept, except everything is reversed. By the way, this isobar in the middle, let's say I want to know what the wind direction is at that point. Where's my higher pressure? Well, here's a high, here's a low. My higher pressure is on this side. I'm not pointing at the low. I'm not pointing away from the high. I'm pointing this way. There's my pressure gradient force, perpendicular to the isobar. My Coriolis force, Coriolis effect, and my wind is again a northwest wind. All right, let's get to the low briefly here. Let's just pick 3 places on the low. Boom, boom, and boom. All right, 3 points around the low. In each of these points, the higher pressure is on the outside of the circle because you're going into a low, which is lower pressure. So let's start with this one. In this case, my pressure gradient force is in toward the low. My Coriolis effect is my pressure gradient force. Here's my Coriolis effect. There's my wind. It's pretty much a west wind. Okay? Now let's go here. Higher pressure on the outside of the circle, lower pressure on the inside. Pressure gradient force is here. Turn it. Coriolis effect is here, and the wind is there. So as I look at that, that's kind of a southeast wind. Finally, this point. Pressure gradient force is in toward the inside of the circle. My Coriolis effect is here to the right, and my wind is there. Kind of a northeast wind. So, what happens in a low? Air is converging, it's coming into that low and then rising. So as it converges, it's being turned by the Coriolis force. So it's crossing the isobars like so, converging but being turned in a counterclockwise manner into a cyclone, which we often call a storm. It is generally unsettled weather, cloudy, maybe precipitation coming down. This would be the center of my precipitation. So that's the way you find wind direction. Start with pressure gradient force, add your Coriolis force, and you put your wind between the two, and you'll find your wind direction.